I suppose some of you want to study for your other tests. I heard 108 test is this week too, isn't it? Thursday? I see. You should definitely, manage your time wisely. Don't wait till Friday or Thursday night to study for 135, especially 102. Okay, if you don't spend time on it, I doubt you can do well on the midterm. By the way, I've seen your midterm already. I just had a look at your quiz 2 result, and based on your quiz 2 result, I'm extremely worried about your midterm. I wasn't quite hard, but it's definitely harder than your second quiz. I don't think anything can be more straightforward than quiz 2. So, average for version A is 52%. Version B, we don't know yet. We're still grading. Midterm took me 16 to 18 minutes. I don't remember. Anyways, how do you recommend being able to study hard and study for 3 midterms? There's more work or study that can be done. As I said, this is what I always say. You should always study smart than study hard. So if your strategy for studying is just grading as many questions as possible, that's not smart at all, and that requires you to spend a lot of time on it. Okay? You should focus on quality instead of quantity. So quality means for each question you do, you should always go back and do some reflection. So ask yourself, what did I learn from this? Can I apply the same strategy on a different type of question? If so, what are the different types of questions that might look like? So one question, after you finish it, it should have like a mind map in your head. For me, that's how it works. Like after I finish a question, I can connect it to many different types of questions that maybe I've seen. I haven't tried, but I've seen them. And I was like, oh, you know what? This question, the method I use here can be used in that question as well. And then from that, I can even keep going and I can think, oh, maybe this type of question, I can use the same strategy as well. Let me give it a try later. So you should have your own mind map. You should have your own connection. You should have your own, strategies you can use when you do proofs. I'm talking about 102, obviously. And for 135, this is pretty much the same, to be honest. Like, for example, okay, so let me give you one example. Like example of what concept we've talked about, but I didn't give you the connection. I didn't talk about more. For example, this because I'm using this because we talk about 1-to-1 in 102 as well in the future. So using this as the example will help you with 102 as well. So let's use inverse. Specifically, let's use 1-to-1 as an example. So when you look at this definition, we did one variation, which is I asked you what is the contrapositive of this. So when you look at this, if I were you, I look at this, I was like, okay, so this is a definition. I know this is how I can show something as 1-to-1. And immediately, since there is an implication, I would think, oh, well, if you take the contrapositive of it, I would get this, which is equivalent to this. So that's another way to show it's 1-to-1. But now, that's not all of it because, well, we also said 1-to-1 is, well, it never takes the same value twice. We also said you can use horizontal line tests. So I would ask myself, well, other than this, is there another way to show it's 1-to-1? For example, what kind of function would be 1-to-1? Any ideas? I'm teaching you how to think now, okay? So this mind map needs to be built in your head. So what do you think? Other than those, how else could be possibly be 1-to-1? Okay, so you're talking about a linear function as 1-to-1. Okay, linear, sure. Cubic function. What about some generalization, not just like a specific function? Anyone? Any other connection you can make? Non-oscillating, or odd function? Is it true? Are you sure? What about sine, cosine? Sine, cosine. One of them is odd, one is even, but obviously both are not 1-to-1. Always increasing. Okay, yeah, there we go. So someone mentioned this is a good point. If a function is increasing or decreasing, right? Strictly increasing, strictly decreasing. So strictly monotonic, it must be 1-to-1 as well, right? That's another thing you can think. Well, so you can write it down so that this is something you through some like just think about some ideas. You can write something down so you can think about 1-to-1. If a function is strictly monotonic, right? So that's also only 1-to-1. Yeah, so someone also mentioned a good point, right? One of you also mentioned a good point. Restrict domain, right? So that's another thing you should keep in mind, right? So it's not we always can restrict the domain to make it 1-to-1. That's another point, right? It's a great point. So those two are some great points here. Why? Because well, if you can come up with those, guys, if you can come up with those, for example, this can relate to many questions already. So for example, if I were a prof, I would say, well, given a function f, they don't tell you what f is. So we can say, well, give a function f, the function is strictly increasing, and give you maybe a little bit more, for example, it doesn't have horizontal asymptote, okay? And they ask you, well, does this function have inverse? Right? So that's something they can ask. They can, well, does this function have inverse? So they can test you, well, you need to argue that, well, since it's strictly increasing, doesn't have horizontal asymptote, must pass horizontal line test, right? So it must be 1-to-1, and since it's 1-to-1, we know that it has inverse. So yes, right? So that's like a nice question already. And here, from this, I can make another question, right? So you can say, well, they can give you a function that's not 1-to-1 if you consider its natural domain. And then they ask you, for example, it's like a polynomial. Okay, they can give you a polynomial, and the polynomial itself is not 1-to-1. And they can ask you, well, under which domain can we make this function 1-to-1? You see, that's another good question. So while you study, if you can brainstorm some ideas of some connections, this little thing can connect to, those like, for example, does, an inverse and so on. If you can do that, then you don't need to do that many questions, because in your head, you already know what type of questions might show up, and you already know how to do them, because, well, you kind of make the question yourself. Like, for example, I made the question like that. So if I see a similar question, I know, well, this is testing me, right? So if you see something like this, you would immediately think, well, this is testing me on 1-to-1. This is testing me on horizontal line test. This is testing me on inverse. So I would know exactly what to do without even trying as many questions as possible. I can know what type of questions might show up. So similarly, you can do this for inverse functions. So if you look at the inverse functions, you can think about what kind of things they can ask. Okay, so that's how brainstorming can help you with a lot. Similarly, like what we said here, like this can show up in 1-to-2 as well. So like, for example, strictly monotonic can be a way to argue that a function is injective. So, and some of you said something like linear function, we know that it's injective, that will be used in 102 in the future as well. So those are some really good ideas. You should keep doing this for all the questions, all the definitions, and all the theorems you've encountered so far. And if you can keep doing this, that's a study smart way, okay? Because if I do this, I don't need to do that many questions. I don't need to run every single questions, because I see a new question and I can make connections. I know exactly what they're testing me, and I have some ideas of how to start it instead of, memorize solutions. It's something you should consider. How difficult would you say compared, or which year are you comparing to? Harder compared to some of them, but easier compared to the others. So it's fair. It's not easy. Meter average last winter semester meter, let's say averages it was 43%. But as I said, sometimes it's harder, sometimes it's easier. So like, eventually we'll balance out. Not just that, sometimes you guys think, oh, I can get the big hint on the homework, so let me just use a big hint Or maybe let's just trick a professor to do a homework question for me, and I'm just gonna copy their solution. Well, it might be good on your homework mark, but that's a terrible idea because, well, if you don't go through the whole thinking process for your homework, you're gonna suffer for your quiz and test. For example, last quiz, you guys didn't know what's if and only if. Why? Because, well, homework 1, question 1, we already talked about if and only if. If you didn't spend effort on that question, of course you would not understand what's if and only if, right? So that's something you should consider. Weakness, yeah, of course you should do your weak topic first. But don't spend all time on it, okay? So every topic, including the ones you think you are good, because the ones you think you are good at doesn't mean you're actually good at it, okay? So some people don't have a good understanding of what they are actually good at. You think you're good at it doesn't mean you're actually good at it. So you still need to study for all topics. Okay, so first, limits. Those I already want to talk about. You should know that limit exists only if left-hand side limit equals to right-hand side limit equals to a specific number. Okay, L has to be a specific number. Well, this should be X. Did you guys notice? Okay, L should be a real number. This should be a real number. It cannot be infinity or negative infinity. Okay, so when we have let's say limit equals to plus or minus infinity, it's actually a type of does not exist. Okay, the infinity or negative infinity is just the behavior of the function when it approach infinity or when it approach a certain number. It does not mean the limit actually exists. Okay, it exists, you need it to be a real number. But if you figured out that it's infinity, you should still write infinity. You should not write does not exist. Okay. That's one thing I want to say. The other thing, just give you a little graph. Let me draw a function. So for example, let's have a hole here, have another hole here, and have another. Okay, so let's say this is my f of x. Okay, and let's say this point, this is A, this is B, and this is my x, this is my y. All right, so let's call this value L. Okay, so let me ask you, what is the limit as x approach to A of f of x?
It's approaching L.
Oh. Okay. This is L. What is the limit as x approach to B f of x? It does not exist. Right, does not exist. Why? Because your left-hand side limit is not equal to right-hand side limit. Okay? They do not equal to each other. The first thing you do is always simplify. So we should think about, well, can I simplify this? Maybe we can factor it out. We can write it as 3 plus x times 3 minus x, but there is no cancellation that can happen, right? Because of that, well, I can move on to the next step, plug in A. Okay, so if I plug in 3, what do I get for this expression? What do I have? 0 over 0. Okay, so if you plug it in, you get 0 over 0. Right? And then you can check my flowchart. I said, well, if you get 0 over 0, you should multiply by its conjugate. And I said most of the time it works. So what is a conjugate in this case?
Would it be square root x plus square root 3?
That's it? What do I multiply?
You multiply it by like square root x plus square root 3 on both sides, on the numerator and denominator.
That's correct. Okay, so you multiply by square root of x plus root 3 over root x plus root 3. Okay, this is the same as multiply by 1. This is basically 1. So it's the same as multiply by 1. Okay, after you do that, and then said, well, what's your next step? You simplify it again and plug in A again, right? So let's simplify it. You'll have limit as x goes to 3, and on top you'll have x minus 3, right? On bottom, now I can write this as x plus 3, 3 plus x and 3 minus x, and root x plus root 3, right? And you can simplify, cancel them out, cancel out, cancel out. Is that it? Do I need to write something else? -1, that's correct. That's correct. Okay, so we'll have a -1 here. Oh. Okay, what do I do next? Exactly, sub it in. Okay, so sub it in. You have -1 at the top, and then you have 6 times root 3 plus root 3. Right, and this equals to -1 over 12 root 3. You can leave it like that, or you can multiply by root 3 on top and bottom, and do more simplification. I mean, it's up to you. Doesn't matter. You can leave it like that. Difference of square on numerator. You mean write? Are you saying write this as root 3 minus root x times root 3 plus root x? Yeah, I mean, write this part as this and cancel out with this. You can do that, yeah, of course. Yeah, but the point here is I want to show you the multiply by conjugate method, so I didn't do that. Okay. I see, I chose this question for a reason. Okay, now B. Again, first I can simplify it, right? Because this is basically a fraction minus another fraction, which I can, common denominator. So this is 1 over 3 plus t minus 1 over 3 over t. Right, common denominator. By the way, I noticed that a lot of people don't know how to do common denominator, which is concerning for me. You have to know how to do it, okay? 3 plus t, and top you have 3 minus 3 plus t, right? If you have that, those two cancel out, and the plus t becomes negative t. Okay, so here is negative t, right? And this can be cancelled with this t. You have a -1 left. So after all those, you have limits t approach to 0. You have a -1 at the top, and then 3 times 3 plus t at the bottom. Okay, this is after simplification, right? And then now I just plug in 0. That's gonna be -1 over 9. C, okay? C. C is the one I really want to talk about. The cancellation I did here. Which part do you not understand? 3 cancel with 3 because 3 minus 3 is 0. Okay, and then you are left with negative t, right? You're left with negative t. And this t and this t can cancel out, so you're left with -1. That's it. Okay, absolute value. You have to know how to do it, okay? Let's copy it down. Know it for 135. You should know how to do any questions related to it. You need to know it for 102 as well. Okay, absolute value, so important. Why? It's not that important. Why do I always test you on this? Because you guys are really bad at those. So anything you're bad at, you should really practice on them. So what do we do? Two cases, that's correct. What are the two cases? Left hand limit and right hand limit. Exactly. Okay, exactly. That's great. Okay. So limit as x goes to 2 from right. And let me write down the other one as well before I actually do it. 2 from left. Okay. So 1x approach 2 from the right hand side. What is this gonna be? Specifically, is the top gonna be positive or negative? The top is gonna be positive or negative? Not x, top. Well, we have different answers. So we're talking about 2x minus x squared. Is it gonna be negative or positive? Is it? So let's do it together. So you're checking 2x minus x squared. Okay, so it's slightly bigger than 2. Okay, this x is slightly bigger than 2. Slightly bigger. So it's around, let's say, like you can think about like 2.01, for example, and then consider this as 2.01, right? Square. Which one is bigger? Is 2 times 2.01 bigger or 2.1.01 square bigger? So is it positive or negative? It's negative, right? It's less than 0. Obviously, we don't want to write this. Okay, so let's remove that. But you can test it, right? You can test it. So this is smaller than 0, which means my top will be negative of inside. Oh no. The people who answered positive, what are you gonna do on your test, huh? Okay, guys, don't memorize it. Don't generalize it. Don't think if it's from the right, then it has to be positive. That's not the case. You have to actually check it. Yes, you can use real number line. It's up to you. If you're confused, just like, check a number. It should give you some idea if you're really confused. Yeah, exactly. Factor x out and cancel out, and then the hard part is down. Okay, the hard part is decide it's positive or negative. Okay, so you can cancel them out. You can cancel out this with this. We're left with minus, but this minus can go away. So you'll be left with limit as x goes to 2 from the right hand side of x, plug in 2, which will give you 2. Now do this one. This one should be really similar. I don't even want to write it. Okay, so do the same thing. This time you have a positive one here, and this negative sign go away, so those two cancel out. You'll be left with a minus 1 here. So you'll be left with a minus x here. So you'll be left with a minus 2 here. Okay, it's the same idea, so I don't want to repeat myself. So what is a limit? Limit does not exist. Okay, so you should write since this does not equal to this, right? And you can say, oh, this does not exist. I'm too lazy to write, so I'm just gonna copy. Does not exist. Question? This clear? And minus x become x because this has a minus 1 here. With this negative sign here, it becomes plus 1. That's why. All right, move on. Evaluate. X cubed minus 27 over 3 minus x. Okay, they already gave you the formula, so they made the question much easier for you. At least I think so. Okay, so to use the formula, right? Use the formula, you have x minus 3 times x squared plus 3x plus 9 over 3 minus x. So those two cancel out. You're left with a minus 1 here, right? So there's not much to do. It's pretty simple. You are left with negative x squared plus 3x plus 9. Plug in 3. You have 3 squared plus 3 squared plus 9. That's 3 times, sorry, there was a negative sign here. 3 times 9, which is negative 27. So this is very clear. B is very clear too, isn't it? Is it clear? B? Okay. B should be clear as well. Those are simple stuff that hopefully nobody have problem with those. Oops. I directly put it in already. My bad. Okay, plug it in, you have 1 over root 0 plus h, 1 over root h. Okay, nothing complicated, right? What about this? For what value of a and b is the statement below correct? What do I do? Any idea? No idea? Conjugate? Multiply by conjugate? Okay, we can do that. That's what you guys do. So let's do that. So you want to do this. You want to do ax plus b minus 3 over x times conjugate. So times square root of ax plus b plus 3 over square root of ax plus b plus 3. Right? Basically, I'm just doing what you guys want to do and give it a try. So you don't really generalize anything. It's basically, math is basically you try things. You know, try and see if it works. So let's give it a try. Oh, why do I keep getting... Okay, so what's top? Ax plus b minus 9. Bottom is x times square root of ax plus b plus 3. Okay, what do I do now? What do I do now? Directly? You're not gonna plug in 0 in there? Gabriel is correct. We need to do something before we do the limit. So I'll set it aside. Before we do this, let's do something else. Okay? I would set those, this expression equals to 1, and see when x equals to 0, what can I have? So suppose this, ax plus b minus 3 over x. Set this to be 1. Okay? X cannot be 0 here because it's in the denominator. But if I move this to the other side, so suppose x is not 1, then I can move it to the other side, right? So I can do this. Okay, and now ax plus b is gonna be x squared plus 6x plus 9. Okay, so this is under the assumption of x is not 0. Okay, so we have this. Now, if x is approaching 0, so think about x is approaching 0. So this is what, like, in my head, I would think like, oh, if when x approaches 0, right, I need b to be what? So if x is approaching 0, this is gone. This is also gone. Both gets really small, so it's almost gone. Then b is what? B is 9, right? So I need b be 9. Okay? So let's change b to 9 here. I will change b to 9 here. And change this b to 9. Then change this b to 9. Okay, so if I do that, they can cancel out. And this x can cancel out with this x. Now you can plug in 0. So you have a over square root of 9 plus 3. Sorry, square root of a9. No, this is 0. 9 plus 3. So that's a over 6 equals to 1. So what's my a? 6. Okay, so a is 6, b. When a equals to 6, when b equals to 9, this equation can hold. So you need to do slightly more observation or do a little bit more before you actually compute the limit. You see, I did not give you a specific strategy, to be honest. When I do those questions, I ask you, what do you think is the correct way to do it? And we give it a try, right? You guys asked me to multiply by conjugate, so we gave it a try. I tried it, and I got stuck. When I get stuck, I'll think about, well, how do I make it not stuck? Is it wrong to assume 0 over 0? I would not make the assumption, to be honest. Like, personally, I would not make the assumption. I would not do limit directly myself. I'll tell you why. It's mainly because there are 2 values you need to find. And I think if you solve this directly, maybe you can find only 1 value. Because remember, if you want to solve 2 variables, you need two equations, but this is one equation. So in my head, I immediately know that doing this directly is not gonna work. I definitely need another equation. At least figure out one thing first, then the other thing may come. So that's what I have in my mind. Does that make sense? Okay. Piecewise function. Yeah, maybe you need piecewise function. Anyway, I'm gonna skip 13 because it's another multiply by conjugate. This maybe as well. I'll skip those two as well. It's nothing, there's not much to talk about. This coming number, okay. Skip vertical asymptote. No, I mean, if you're given a function, what is the first thing you do to figure out what the... Okay, so you're saying if we know A, right? That's correct. Set the denominator to 0. That's what we do, okay? Set the denominator to be 0. Okay. Find it first, right? You want to find it first. It's one. It's one the denominator is 0. Is there any other cases that might happen? Whole? What do you mean? A whole can happen. Yes. I mean, other than denominator equal to 0. Yeah, like long, inside long, this is 0. It's possible. Those are possible candidates. Okay, and of course you need to check a limit later, but those are the possible candidates. Anyway, so what are the vertical asymptote? Where is my... That's correct. Okay, so you should write it down. So you should say this has infinite. So f has vertical asymptote. Vertical asymptote. One denominator equals to 0. And this equals to 0, right? And this is 1 x times x minus 4 equals to 0. So that means, well, x equals to 0 or x equals to 4. Right, so those are my candidate. Now you need to check limit. Limit as x approach to 0. You can just check one-sided, okay? It doesn't even need to check both-sided. But, well, which side do I check? F plus or minus x squared. This is, I can see you guys are memorizing things again. You're memorizing again. If you memorize, you'll make a mistake. X squared minus 4x. If we approach from the approach to 0 from this side, then this is like, let's say 0 0.0. Oh, we're talking about 0, yeah. 0.01 square. This is 0.01. So what is this? Is it positive or negative? This is less than 0. Did you learn your lesson about memorizing stuff? Did you guys learn your lesson? You learned your lesson? Don't memorize stuff, okay? You should always check. Actually check. Okay, so we need to pick the left-hand side. Okay, so plug in 0. What do I have? Top is... You don't understand? Because if I pick from right-hand side, this is less than 0. If it's less than 0, this is not defined. Okay, you need to pick from the left-hand side for it to be positive. I already told you. This side is approaching 0 from the positive side. And this is positive or negative. This is 1, right? So the whole thing is positive infinity. This tells us that x equals to 0 is a vertical asymptote. Okay, and then we do the other limit. Please, let me tell you, please, guys, please stop memorizing stuff. You have to actually check. Okay? Yeah, let's do it again. X approach 4. Which side? Plus or minus? Plus or minus? Do your math, okay? Stop memorizing. Do your math. Actually, check. Check x squared minus 4x is a positive or negative when you go from positive or negative side. Right side, left side. You know, try a number. If you're really confused, really confused, try a number, you know. Try a number that's slightly bigger than 4 and try a number that's slightly less than 4. So which one? It's plus. That's correct. Okay, do your math. Stop memorizing stuff. That's what I want to say. You gotta do your math. Okay, so again, we are approaching 0 from positive side. And again, top will be, oh, sorry, top will not be the same. Top will be 25, but the whole thing is still plus infinity. So x equals to 4 is also a vertical asymptote. So my vertical asymptotes are those two. Move on, move on, move on, move on. Well, yes, it will depend. Sometimes, okay, sometimes doesn't matter which one you pick. In this case, it does matter because I have a square root. Okay, I have a square root. I need to make sure whatever is inside my square root is positive. But a lot of time, it doesn't really matter which one you pick. Part 2. You know there is a part 2? You think we're done already? We're not done yet. The common mistake here is remember to use the first few that has F and G, those. You need to guarantee they exist first. Okay? If they don't exist, or you don't know if they exist, then you cannot use them. Make sense? This is important. This is common mistake. If you don't know they exist or not, then you cannot split them up. If you know they exist, they equal a specific number or something like that, then of course you can do them. That's the common mistake. Without knowing they exist, you cannot split them up. Now let's try example 1. F, G are continuous function. And limit as x goes to 2 f of x equals to 4. And the limit of this whole thing equals to 4. Find g of 2. How do we do it? What would you do? What do we do if there's only, you need to find some other way? Okay, you might ask me what way, it depends. Okay, there is no specific way that works for everything. Separate element, so you want to start with this? Is that what you're trying to do? Okay, so let's do that. Well, okay, you see, I don't give you a specific way. I ask you what would you do, and you can suggest something that's based on your thinking process, and we can try what you want to do and see if it works. That's how you learn, you know? If I give you what I think, then there is no learning here. So we can split it to 3 times limit x proportional to f of x minus 5 limit x approach to 2 g of x by the limit laws above. And what do we do?
You sub in the limit f of x, so that's 4 multiplied by 3, and then
3 times 4 minus 5 times limit x goes to 2 g of x.
then you isolate for the limit.
12 minus this equals to 4, right? 4. So limit x approach to 2 g of x equals to 12 minus 4 over 5, which is 8 over 5. Now what do we do? We're looking for g of 2. We have a limit. What do we do? What do you do? That's correct. You need to mention that. Okay? It's because it's continuous. Okay? You need to mention it. Mention it. Since g of x is continuous. G of 2 is just the limit x approach to 2 g of x, which is 8 over 5. Is there anything else you need to mention? Is there anything else I need to mention for the solution? If you don't know if it's continuous, so we don't know what g of 2 is, there is nothing you can say about it. Okay? There is not a thing. We don't even know if it exists. But, okay, here, when we split it, remember I said we can only do this if they both exist. Well, here they told us exists, but why? How do we know this one exists too? How do we know this one exists too? Why? It's continuous, that's correct, okay? Because it's continuous, so should mention it. Since G is continuous, limit exists. And we can use the limit law. So now we're good. What color is your test? What color is my test? You mean the test I did? For your meter? Is that what you're asking? I mean, you can see it's clearly white, right? Okay, square theorem. What does it mean? What do we do? When do we use it? What do we do? Bounded function, okay. What are the conditions we need to use? I mean, we need to satisfy inequalities. Huh? Inequalities, yes. So you want your target function to be in between two functions. So it's like, it's being squeezed by two functions. Okay, that's why it's called squeeze theorem, right? So like this. And then, I'm being squeezed by those two functions at this point. Like, I'm being squeezed at this point. A, this is your gx. This is h of x, this is f of x. So g of x is like, stay away from me, but they keep squeezing him, okay? And then because it keeps squeeze and squeeze and squeeze g of x, at this point, they should have the same limit, right? Okay, at this point, they should have the same limit. So if you find the limit of those two and they're the same, then the one that's being squeezed would have the same limit. So as we mentioned before, you usually use it on bounded functions. What do you mean, what's going on? Which part is not clear? Oh, okay. So, yes, so as I mentioned before, usually if you see bounded functions like sine, cosine, it's very likely, or if they give you something that has like inequality there already, it's very likely you need to use other than trig. I don't know, it's hard to say, because there are many bounded functions. You know, and another way is like they can give you inequality like this directly. Then it's a huge hint that you might need to use square theory. Okay. Quadratics are not bounded. They're bounded below or above, but it's not a bounded function. Maybe. Why not? We can give you inequality. So you have f of x, which is in the middle of two functions. They asked you to find the limit. What do we do, guys? What do we do? You what? So as I said, squeeze theory, you need one inequality. Okay? That's a function being squeezed by two other functions. Right? And then what do you need? You need to make sure the two functions that's squeezing your function, they have the same limit. Okay, if they have the same limit, you can say, well, you have the same limit too, right? So here I have an inequality already. I need to find the limit. So what do? There is only one thing to check now, which is this, right? So let's check their limit. See if they're equal. That's it. Limits as x approach to 3. We check 3 because that's what they're asking. Okay, because here is a find limit as x approach to 3. So that's why we do it. Cosine pi x is cosine 3 pi. What's cosine 3 pi? Should not get this wrong, guys. It's -1, that's correct. All right, we're done. No, we're not done. We're done with the first part. Now check the limit of this part. Limit as x approach to 3. And it's complicated, not very complicated. 4 minus x times x squared minus 5x plus 6 over 3 minus x. What is the limit? What do we do? Factor and canceling. That's correct. Okay, that's great. Limit x approach to 3. Factor 4 minus x times x minus 3 times x minus 2 over 3 minus x. There's always a -1 here, right? And then you have limit x approach to 3 of -4 minus x times x minus 2. Plug in is -1 times 1, which is -1. Okay, so what do we do? Can you stop here? You should make your conclusion, okay, based on squeeze theory. You should mention squeeze theory. Remember, if you use something, you should mention it. So, by squeeze theory, because they have the same limit, right? By squeeze theory, since that's equals to, so I would write a little bit more just to be clear. Since they are equal, and the other thing is the C inequality. So I'm gonna copy and paste here. Since this and this, okay, that's why we know that the limit x approach to 3 f of x. So this is -1. So this should also be -1. And that's the end of the question. Anyone who don't understand anything? Yeah, it's basically that. You should know. You should know the value of this, by the way. Okay, hold on. Extra practice for you. Extra practice for you. Continuous. Continuous. 3 types of discontinuity. I already talked about this. You're continuous if left-hand side limit equals to right-hand side limit equals to the function value. So discontinuous, there are 3 types. What are the types? You guys know? Dump, infinite, removable. That's correct. The graph, I feel like if I give you a graph, everyone knows, but I'm more concerned about if you don't know a graph. If you don't know the graph of the function, how do you know what kind of discontinuity you have? Anyone? Check limit. That's correct, but how can the limit tell us what type of discontinuity you have? I have so many questions. I think this, for example. If limit exists, then removable. Okay. Limit exists and what? Okay, so the last one is simple. If the limit is plus or minus infinity, that's correct. So let's call it this A. Let's call this A as well. Limit as x approach to A, either plus or minus f of x. If you can get plus or minus infinity, then you have infinity discontinuity. Removable, someone mentioned it as well. If the limit exists, but it does not equal to the function value f of a, then you have removable discontinuity. What about jump discontinuity?
If the limits don't match with the f of a.
That's correct. Okay. Limit don't match and you are not infinity or negative infinity, okay? So left hand side limit does not equal to right hand side limit. And limit is not plus or minus infinity. Cool. So if you know this, less worried. There are some theories. So if it's continuous, you add them together and multiply them together. Those are still continuous. If you multiply by a constant number, still continuous. There is a bracket missing here, divide. So rational, pretty rational, still continuous. And you should know that those functions are continuous in their own domain. So if f is continuous, this we actually use a lot. If f is continuous, you can actually pull it out from a limit. So you can take it out like that. So you'll get this. We use this a lot, by the way. Okay. And composition. If f and g are both continuous, g is continuous at a, f is continuous at g of a, then the composition is also continuous. So that's something you should know. Let's do another absolute value question. Absolute value. The third one, this one. It's basically saying if f is continuous, then you can take it out from the limit. So you can do limit first, or you can do limit later. So if, for example, if you have a limit as x approach to a ln of 3x plus 1, this is the same as you do limit of 3x plus 1 first. And then you do long. That's all it means. Yeah, basically. Okay, so let's give it a try. For what value is f of x continuous, and for what value it is discontinuous. For each discontinuity, determine if it's junk, removable, or infinite. So someone mentioned discontinuous x equals to 6 and 4. How did you get that? That was your thinking process. Why 6 and 4? Denominator is 0, exactly. Okay? So from this, let's let this be 0. You'll get x equals to 4 or 6. So let's compute the limit. Okay? Let's compute the limit. So limit as x approach 4 from the right hand side. Top I'm gonna let's write first. Okay. So here is your question. If we approach 4 from the right hand side, what's gonna happen to my absolute value? Is it gonna be positive or negative? Absolute value. Say yes, that's correct. Okay, this is a simple one, I suppose. So what do we do? Now what's going on? It's gonna cancel out. -1 here. So it's the same as plug it in. You have -2 x at the top and x minus 4 at the bottom. So top will give us -8. What about bottom? I'm approaching 0 from positive side or negative side? Approaching 0 from positive or negative side? From positive side. So what is my final answer? -infinity. That's correct. Okay, so the other side is quite similar to that, so I'm just gonna copy paste. Okay. Only do the same thing once, so the explanation will be pretty much the same until here. Okay, so now, am I approaching 0 from positive or negative side? From here, am I approaching 0 from positive, plus or minus, guys? Plus or minus? It's minus, that's correct, from negative side. So what's my final answer? Infinity, that's correct. Okay, so let's just remove the negative sign now. So, what kind of discontinuity do I have? Infinite, okay? So, at x equals to 4, we have infinite discontinuity. Do the next one. Yes, that's correct. Still infinite. If you have infinite, then it's infinite. Okay. Okay, let's copy it again. Now let me do some changes. Change this to 6. Okay. If I change this to 6, so this is gonna change. Maybe this whole thing is gonna change. Yeah. If I change it to 6, is my absolute 6 from the right hand side. Is my absolute value positive or negative? Okay, that's great. So this I need to add a negative sign here. It's negative. Okay. So now those two cancel out with a negative sign. I'm gonna have, sorry, this should be 6 as well. 6. I'm gonna have 2x over x minus 4, which is what? Which is you plug in 12 over 2. So it's 6. Okay, and you do the same thing for the other one. Now approach 6 from the left hand side. What do you guys think? Do I have is it positive or negative? Inside of the square root. Not square root. Inside of absolute value. So is this stay positive or negative? Plus or minus? Plus or minus? Plus. Okay, so I'm gonna remove this minus sign. So those two cancel. Those two cancel out. I'll be left with a -1 here. So top I'll have a negative sign, negative sign, and negative sign here. It's a 50-50. Do not guess, okay? Don't guess. Just plug in a number, pick a number that's smaller than 6 and give it a try. If you want to talk about really formal, then you should not take 135, by the way. Take 137 or 157. So we'll do it the formal way. None of this is formal anyway. Anyway, this is good. IVT, guys. Are you excited? At 6, there is a vertical asymptote. Didn't we just showed you? It's not infinity, so there is no vertical asymptote here. You call it vertical asymptote, then you need to make sure the limit is infinity. Oh, that's from last part. Remember? Do you remember? Last part we talked about if you call it vertical asymptote, you need to check the limits, make sure it's. That is why I said those are just candidates for VA. Your vertical asymptote, those are just candidates. They're not necessarily actually a vertical asymptote. You need to compute the limit to make sure it's actually vertical asymptote. IVT. Well, you learned something today. You learned that you cannot just memorize stuff. It's not always positive or always negative. You learned that when this is 0, it doesn't mean it has to be a vertical asymptote. You need to check it. IVT. When do I use IVT? What does it mean? Anyone wanna share with us your opinion? What are the conditions you need to satisfy? First of all, which conditions you need to satisfy? Continuous. That's correct. First keyword is continuous. This is really important. Continuous. And what? Can there a case where one side is a value, the other side is infinite? Of course. Then it's still infinite discontinuity. Okay, so one continuous. You also need closed interval. Closed interval. Okay, and 3 is this. So you need f of a less than n less than f of b, or this, doesn't matter which one it is, but it has to be in between those two, and they don't equal to each other clearly because I used strictly here. Then there exists a number c in AB such that f of x equals. All right, so thus most likely is used to check to show the classic question here. Classic question is to show an equation has at least one solution. Okay, so this is mostly used to show has at least one solution. You don't need to prove IVT. You can use it directly. It's not a proof course. For 137 people, they might need to prove it. I think they should prove it. Yeah, you can assume it's proved already. All right. Most of the time they will ask you to show some equation has at least one solution. So what you need to do in this case, so you need to first check. First, right? So step 1, you put everything on one side. So this equation, put everything on one side and call it your f of x. So put everything on one side. For example, if you move everything to the other side, then this will be something minus this equals to 0. So f of x, check if it's 2. Check if f of x is continuous. Okay. 3, find a such that f of a is greater than 0. Find b such that f of b is smaller than 0. And then you can use IVT now. Okay? You can use IVT now once you've done everything, because well, I have continuous in a closed interval a, b, right? And I find f of a, f of b, where 0 is my n, because to show it has solution, we need to know if it can equal to 0. So 0 is 0, and you find 0 is in between two numbers, and they don't equal to each other. So we know that there exists a number in this interval AB such that the function equals to 0, which means it has a solution. Okay, so that's the concept here. So let's try this. Does that make sense? Does that make sense? How this would show that it has a solution? Yeah, mostly the one you will see in 135 is used to show a solution. It's the most classic question in 135 for IVT. Let's let f of x equals to, so put it on one side, x squared minus sine x minus x cosine x minus 17. You need to give some, you need to try a little bit. Okay, so this is continuous. Why? Because, well, it's a sum and difference of a bunch of continuous function. And before we talked about if you sum two continuous function together, you'll get a continuous function, remember? So this is continuous everywhere. So we have 1 and 2 already. So let's find 3. So what would I pick? I would definitely pick something I know values of sine x and cosine x already. Right? I would definitely pick something I know the value for. So for example, let's try 0. Let's try 0. 0, f of 0 equals to 0 minus sine 0 plus 0 times cosine 0 minus 17. So all of those are 0 minus 17. So this is negative 17, which is less than 0. So well, I finished this part already. So let's try something that makes it positive. You can say it, but you can also justify it. You can say, well, it's continuous because it's a sum of some continuous functions. You can do that. Okay, so try something. We have some suggestion. I would not use 1, okay? Because 1 sine 1, you cannot get a specific value. I just said that because this is continuous, this is continuous, this is continuous, this is also continuous. If you add them together, it's still a continuous function because, well, here, sum of continuous function is also continuous. Product of continuous function is also continuous, right? So this x cosine x is a product of two continuous functions, so it's still continuous. So I would try something like pi over 2. You know, those values will make more sense to me, at least. So let's try pi. Will pi work? Anyone try? Pi squared minus sine pi plus pi cosine pi plus 17. Oh, minus 17. This minus. What am I doing? Okay, so what is this? What is this? Sine pi is what? Sine pi is 0. What about cosine pi? Negative 1. So what do I have? I have pi squared plus pi minus 17. Is it positive or negative? Do we know? It's still negative, right? So it doesn't work. This one doesn't work. I want a positive one. So let's use something bigger. Because it doesn't work many because pi squared is not big enough, right? So let's pick something bigger. Let's pick like 3 pi squared, for example. 3 pi. Okay, it's bigger. 3 pi instead. You see, if it doesn't work, we try a different one, okay? Then that's what we do. 3 pi. It's not like I immediately know what to do. Why do both A and B have to? It doesn't have to be. Doesn't have to be. Okay? Does not have to be. You can use negative pi as well. 3 pi. That's gonna be 3 pi squared minus sine 3 pi. What's sine 3 pi, guys? Sine 3 pi is 0. What about cosine 3 pi? That's negative 1 again. So now I have what? I have 9 pi squared. Oh, this one is big, right? Plus 3 pi minus 17. This is definitely positive. So we're almost there. You see? So I have 1, I have 2, I have 3, I have 4. Nice. Let's use IVT. Okay. So you can use IVT to make your conclusion. So you mentioned that you have all the conditions satisfied already. So you can say since let's make an inequality. So since f of 0 is less than 0 is less than f of 3 pi. So I'm talking about my n is in between those two numbers. Okay, we can apply IVT to f on interval 0, 3 pi. Okay, then by IVT, we know that there exists C in 0 to 3 pi, right? Such that f of C equals to 0. It has a solution. In other words, the equation has at least one solution. We don't know. Isn't it just always 0? Sine 1 is 0? Are you saying? I mean, you know approximately sine 1, but it's hard to write it as an exact value, you know? Yeah, that's why I said you want to pick something you can write up. So let me ask you a question. As I said, we learned something from the question, right? Well, what if I said, let's change the question and see what's going to happen. What if I ask you to show that it has at least 2 solutions? What are you going to do if I change it to at least 2 solutions? Cry? Of course you're not going to cry. Because in IVT, the condition is closed interval, but the conclusion is an open interval. Basically, all you need to do is you find another value that's smaller than 0. So you add another one here. Sorry, no, I mean you have a smaller than 0, you have a greater than 0. If you have another smaller than 0, then between the smaller, another greater than 0. Sorry, if you have another value, let's say smaller than 0, let's say like f of 3 pi, negative 3 pi, for example, right? It will be positive again. Then in between negative 3 pi and 0, you must have another solution. So you just use IVT twice on 2 different intervals. Yeah, basically. Okay, so it's the same thing. Do you guys see that? Even if I change it to 2, it's still the same thing. So don't cry. Think about what you can do. Okay, it's the same thing. There is not much to. It's not. We're giving you something really hard. Does that make sense? How if I change it to 2, you can still do it. Something more negative. No, not something more negative. It's basically you find another interval for it to work. Give it a try, guys. Just give it a try. So basically, we're saying in this interval, you have one solution. If you want to show there is another solution, then you show that in a different interval, you have another solution. Then you have 2 solutions. Does that make sense? That's all you need to do. You find a different interval and show that there is a solution there. So you have at least 2. Pick the interval as well. Just try. Right? Just give it a try. Like for me, that's what I said. I will pick f of negative 3 pi. This is basically this and greater than 0. So I can pick negative 3 pi to 0. That's my other interval, right? You don't have to. don't have to. It's okay. Don't have to make it small. If you only use if you only use 100 pi, then go ahead. It doesn't have to be small. Okay. Make sense? I just want to quickly explain why this works. Okay. Quickly explain why this works. Why this is a limit definition. So let me explain it to you. Hopefully you can understand what's going on instead of just memorizing it. Basically this is what happens. So if I have a function, let's call it f of x. And you guys know that the derivative or the slope is the slope of the tangent line at a certain point, right? You guys know that? So for example, I want to find the slope at this point. Then it's the slope of the tangent line. Oops, didn't look good. So it's the slope of this tangent line at this point, right? This is clear for everyone. But the thing is, how do I find it? So instead of doing it directly, we have a second line instead. So instead of having that, we have a second line between, let's say, 2 points, connect 2 points. So this is a second, very clear here. But let me move it, maybe like this. Okay, this looks more clear. So we have a second line where we have A and f of A here. And you have, and let's call this point A plus H. The H is the difference between them. Okay? Yeah, I'm talking about second line. I am talking about second line. So look at the second line. Then here would be A plus H and f of A plus H. Right? This is, if you look at the second line, do you guys agree the coordinates here? So far, so good? Okay, so how do I go from a second line to tangent? How do we do that? We basically, well, before that, okay, just before that, how do we find the slope of the second line? What is the slope of the second line? Is rise over round, right? So it's f of A plus H minus f of A over H. Agree? This is the slope of the second line. Right? Yes. But now, to get from second line to tangent line, you basically move this point closer and closer and closer and closer to A, infinitely closer, which means as H, the distance between them goes to 0. Do you guys agree? If H goes to 0, we will have a tangent line instead of second line? Yes. Okay, so as H goes to 0, my second is gonna go to a tangent. So the slope of the second will be the slope of the tangent, which is 1 when H goes to 0. This is gonna be the slope of my tangent line. Does that make sense? Why this is the slope of the tangent line? Make sense? Okay, that's great. Did you guys know this in lecture? I feel like they really should tell you why this is correct. No? So you didn't know why this is the definition? You just memorized it? The whole time you just memorized it? You know in high school, that's great. Okay, so derivative, which is like the same thing here. So what I want to mention is a few things you should know. Okay, so for example, when f prime of x equals to 0, what does it mean? We have a horizontal tangent. What does it mean? I meant horizontal tangent. What does it mean for f of x? It's a turning point. That's correct. Okay, point. For f of x. That's correct. What about f prime of x is greater than 0? What does it mean for f of x? Positive slope. Then your f of x will be increasing. Okay, and similarly, if it's less than 0, slope, you're decreasing. You should do more application questions. When can you sleep? You can sleep anytime you want. Maybe one application question is gonna show up here. Okay, so application, so it's like word questions. They give you a paragraph, like for example, position. So this you should know. The derivative of position is what? Derivative of position is. You don't need to know concave up down. That's for later. velocity. This is only to help you to understand the graph, okay? This you will learn this properly later. Right now, just for you to understand the graph, like why is it going this way? Yeah, that's a second derivative. This is not officially nerd yet, okay? Just for you to understand it. What is a derivative of velocity? Acceleration. Okay, great. Okay, so you might have like an application or word question here. You should do more from your textbook or something like that. Now, at the very end, we're gonna do some limit definition. Did you guys learn differentiable or no? Just confirming. Yeah, it's gonna be on your test. Okay, so we have two more. Use a limit definition to find f1. Use a limit definition. Let's do it. Is a limit as h goes to 0. Now you can have t equals to 1. So s, let's write it as s1 plus h minus s1 over h. So that's limit h goes to 0. S1 plus h, which means you replace every t with 1 plus h. Okay, minus square root of 1 plus h squared plus 3 plus root 3, and then minus 1 minus 1 plus 3 is 4, so 2 plus root 3 over h. And this you can cancel out a bunch of stuff. There is 1 and minus 1 canceled out. There's root 3 and minus root 3 canceled out. Right? So far so good? Yeah, I use rule to check my answer too. I always do that. I always use it to check my answer. Just making sure everything is correct. Limit h goes to 0. You have what's left for you. So we have h minus square root of 1 plus h squared plus 3. What else? Minus plus 2 over h. Okay, so h, this h and this h cannot cancel out. Yeah. So what do we do? Are you stuck here? Are we stuck here? Conjugate? Yes, but before that, I'm not gonna use conjugate directly. I'm gonna write it as two things first. I'm gonna remove this h first. I'm gonna write it as 1 minus this. So then multiply by conjugate is easier here. Okay, now you can multiply by conjugate. How did we get here? This over this minus this over this. So multiply by conjugate. 1 plus h squared plus 3 over the same thing. Let's put it in a big bracket. Okay, and continue. By the way, don't split this and this as two limits yet, because we don't know if this exists yet. You cannot make the assumption. So don't do that, just do them together. So top you have 1 plus h squared plus 3 minus 4. And bottom you have h times this whole thing. Okay, and simplify it. So this is minus 1. Right, this is minus 1. This is minus 1. What do we do now? 1 comes from h over h. So what do we do now? Can I plug in h equals to 0 yet? No, guys, no, not yet. You still have a h multiplied by this, so it's still gonna be 0 in the denominator. So not yet. Expand is correct, okay? So let's expand and see if you can simplify even further. So you see, this question is more complicated than usual. You need to do many things. I would give you a question like this if I were your professor. That's why you don't want me to be your professor. Okay, now we are happy. Do you guys see? Because now, where is this coming from? My bad. Let's put it here. Okay, so now you can see that this 1 and -1 cancel out. This h can cancel out now. Because they can cancel out. So now you can plug in h equals to 0. Okay, before that, you cannot do that yet. So now it's 1 minus top is 2. Bottom is 2 minus. I think we made a mistake. Oh, you guys see it? Here, from here to here. This is without bracket, but if I want to group them together, this negative sign need to be applied here. That's where the mistake is. Yeah, it should be -2 here. And those will change to +2. You guys see it now, right? So here they're separate, so it's okay. But if I want to group those two terms together, I want to put a bracket here, I need to change this to negative. That's where it is. Make sense? So let me see if there's anything else we need to change. This is still right? 1 minus 1 plus 2. Okay, so we're good now. So this is 2 over 2 plus 2, 4. Which is 1 over 2. Make sense? So we made a mistake here when we separated. Because when you separate it, you should be more careful. So I'm gonna leave you to do 9. It's, if I remember correctly. Yeah, this is correct now. Yeah. So right now it's correct. That should be simple. I think you just count the denominator. There might be some a little bit messy stuff, but let's talk about differentiable, right? Differentiable means that f prime of a exists. Yeah, I feel bad for them too. I feel like nobody can actually watch the whole recording. This is the last page. After this page, we're done. I feel like if they're not here, it's really hard to finish the recording. It's impossible. I would never finish it. It's differentiable when f prime exists. So you cannot take derivative directly and call it, oh, this exists. Okay, so this exists means that you should check if the derivative exists. In other words, you should use a limit definition, compute the left-hand side definition with right-hand side definition, and see if they equal to each other to say if it exists. You are still on campus? That's crazy. Go home. And there are 3 different types of not differentiable. One is when it's not continuous, right? It's discontinuous. So this, we have 3 types. You guys already know that. The 2 other ones I want to say are more important. One is corner. One is vertical tangent. Corner or cusp look like this. Why is it not differentiable? It's because at this point, if you approach from left-hand side or you approach from the right-hand side, you have different slope. That's how you do it. Okay, so you can have something like, oops. It's because if you approach 2 sides, you have different slope. That's why it's not differentiable. You cannot reach an agreement with what the slope is. Does that make sense? Why it's not differentiable? Because at this point, if you approach the slope, if you approach from the side, you get a slope which is like positive. From this side, you get another slope which is 0, so they don't agree. So it's not differentiable. Second point. No, it's just like continuous. If it's continuous at every point in this interval, then it's continuous at this interval. So if it's differentiable at every point in this interval, then it's differentiable in this interval. Does that make sense? That's all it means. Vertical tangent. Looks like kind of like this. So at certain point, let's quickly finish this guy quickly because I'm really tired. But tangent is vertical. So you basically remember rise over run. Your change of x is 0, right? So a rise over run does not exist. That's why it's not differentiable. Okay. So what kind of question can they ask you? Oh, before that, remember if it's differentiable, then it's continuous, but continuous does not mean differentiable. Continuous does not mean differentiable. Differentiable means continuous, but they're not equivalent to each other. So a lot of time, what the question they ask you is like a piecewise function and ask you when is it differentiable. This is the type of questions. Okay. What type of question is like this? So what do you need to do? I'm so tired. I don't even want to continue. You first need to check if it's continuous. Okay, because if it's not continuous, it can never be what is it? It can never be differentiable if it's not even continuous. So you should always check, is it continuous first? If it's continuous, and then you check if it's differentiable. So how do we check if it's continuous? What do we need to do to check if it's continuous? Check limit. Oh, that's correct. So you want to check continuous first, so you should check limit. We want it to be continuous at 2. So that means limit from both sides should be equal, right? So let's compute them. And should equal to 2 f of 2 as well. So f of 2 is 2 minus 4b. This is f of 2. And then check the two-sided limit as well. From left-hand side, you have 2 minus bx. Well, technically, you should start with f of x and write that. It's more clear. F of x equals to limit x goes to 2 from the left-hand side, 2 minus bx squared, which is 2 minus 4b. And check the other side. Limit x goes to 2 from the positive side, 3 plus 2b minus 4bx, which is plugging 2, so that's for 7 minus 7, well, not even 7, there's a b. So 3 plus 2b minus 4b? No, minus plus 2, 8b. Right, 8b. So what is this? This is 3 minus 6b. Okay, so this side is continuous. That means they have to equal to each other. Continuous, which means that 2 minus 4b equals to 3 minus 6b. Okay, makes sense? So you have what? You have 2b equals to negative 1. No, 1. So b equals to 1 over 2. Okay, so you're done with this one. Real number such that it's continuous at x equals to 2. But we also want to show it's differentiable here. Okay, or real number b such that f is also differentiable. So you need to use definition of derivative. Okay, definition of derivative. But before that, yeah, you could, yeah, because you might just get one from continuous, one equation from continuous, and another equation from differentiable. So they would not ask the first part. They'll just ask you maybe the second part if you have two variables. They might just say, oh, we'll solve AB such that it's differentiable at 2. Okay, so you might just get one equation from continuous, the other equation from differentiable. Combine them together, you'll get two variables. Make sense? So before you do that, we know that for it to be differentiable, it must be continuous, right? So for f to be differentiable, it must be continuous. Okay. And only when it's at only when this is true, when b is 1/2, we know that it's continuous. So we're just checking if it's continuous when b equals to 1/2. There is no other value, because any other value would make the whole function not continuous, right? So there's no other options. It can only be 2. So we just need to check if f is differentiable at 2, when b equals to 1/2. So now my new f of x becomes 2 minus 1/2x squared if x is less than or equal to 2. 3 plus 1 minus 2x. So that's going to be 4 minus 2x if x is greater than 2. Okay, so now I need to check if this is differentiable. And to do that, we need to use definition, right? So limit as x approach to 2 from left-hand side. Okay, this time I'm going to use a different definition. Instead of h, I'm going to use this. Okay, it's the same thing, because it's basically using a plus h minus a. Okay, same thing. So x approach to 2, and you have f of x minus f of 2 over x minus 2. Okay, and you need to check from the other side as well. This is a slope, right? This is slope. Okay, and from two different sides, you would have two different f of x. So the left-hand side, you have 2 minus x squared over 2, right? Minus, when it's 2, that's 4 over 2 is 2. 2 minus 2 is 0 over x minus 2, which is 2 minus, which is we can factor out -1/2. You have x squared minus 4 over x minus 2. And they can cancel out. We'll be left with x plus 2. So plug in 2, you have 4 minus -2. Okay? You can use either equation, what do you mean either equation? I picked this because it's approaching 2 from the left-hand side, so it's smaller than 2. I didn't pick them randomly. I suppose that's why you're asking. Did I answer your question? Okay. Oh. You mean a I chose this one because it's easier for me to figure out which one I want to use. You use x approach 2 from left-hand side, right-hand side. It's easier for me to figure out which function, which piece I'm going to use. If you use h plus h minus, then it takes some effort to figure out which one you want to use. That's the only reason. Okay, so in this case, this is easier. But in other cases, if it's like something like this, I usually use the h one. But it doesn't matter, they're the same thing. Okay? That's the only reason, because it's easier for me. I pick whichever one is easier for me for that specific question. Minus 2, it's also 0. Over x minus 2. Okay, so this can factor out 2 as well. So that's 2 times 2 minus x over x minus 2. So cancel out. You also get -2, so they equal to each other. Right, so you can say since they equal to each other, left-hand side limit equals to right-hand side limit. My f prime of 2 exists. So it's differentiable at 1/2. b equals to 1 over 2. That's the whole question. Does this make sense? I know it's late and you guys are probably tired too. Focus for like 3 hours is hard, isn't it? Okay, so hopefully this will be helpful. Maybe I'll give you more questions to do, depends on how free I am. And I think we should all go to sleep. Okay, so good night, everyone. I hope you're not gonna do more study. You really should not. Don't study more. You should just take a break and sleep. All right, so good night. Good luck. And study 102, okay? The whole reason of me helping you on 135 so you can study 102. So don't disappoint me. Good night.